Hello viewers, welcome back to my YouTube channel, Science Demystified. Now last time we looked at resonance effect. Remember, I've been running this topic for some time now. We are talking about organic reactions and mechanisms. So last time we stopped at resonance effect, and I promised us that, and I'm going to continue with inductive effect and then other parts of the topic. So what is inductive effect? For you to understand inductive effect, then you need to understand the difference between sigma bond and pi bond. Because resonance effect occurs where we have pi bond, but inductive effect occurs where we have sigma bond. Then the difference between pi bond and sigma bond is how these bonds are formed. Sigma bond is formed by head-on overlap between s and p orbitals, while pi bond is formed by side overlap of unhybridized orbitals of two adjacent atoms, resulting to the formation of an electron cloud. So this is what I mean. Supposing you have two carbon atoms, as you can see clearly from there, and supposing you have two carbon atoms sitting adjacent to each other like this, we have two carbon atoms, and then this is the shape of p orbital, which is called a dome shape, and then we have another p orbital sitting adjacent to this one. The resultant effect of this side overlap is having electron cloud at these 2 points. So when these lobes overlap, they form an electron cloud above, where we have the nucleus of the atom. And these lobes down here overlap to give this electron cloud. So electrons are only allowed to move in the nodal region or the nodal axis of the electron clouds formed. Now you can see that in the formation of pi bond, the electron cloud is far away from the nucleus of the atom. It is not directly attached to the nucleus of the atom. So that is why pi bonds are weak, because they are not directly attached to the nucleus of the atom. They are not directly attached to the atom. So electrons move around this nodal region. That is what we call pi bond. But in sigma bond, there is a head-on overlap. There is a head-on overlap between the electron cloud of two adjacent. For example, suppose we have something like this. So these are electron clouds. So when they overlap each other, they result in the formation of what we call sigma bond. So sigma bond is a very strong bond because it results from the overlap of hybridized atomic orbitals, while pi bond results from the overlap of unhybridized atomic orbitals. Okay, now without wasting much of our time, let us go straight into inductive effect. Inductive effect is an electronic effect triggered by the movement of electron in a localized orbital. The localized orbital is a localized bond. A localized bond is a sigma bond. And for this electron to move, one of the participating atoms in the bond must be more electronegative than the other. So when you have two atoms bonded together and one is more electronegative than the other, the electron tends to move towards the more electronegative atom. For example, if we have a bond between carbon and chlorine, for example, let's look at the case of chloromethane. This is chloromethane. Now between carbon and chlorine here, there is a bond, which is sigma bond. Now, because the chlorine here is more electronegative than carbon, the electron drifts towards the side of chlorine because chlorine is more electronegative than carbon. So once the electron gets to the side of chlorine, it makes the chlorine to acquire a partial negative charge. And then the side of the carbon, where the carbon exists, becomes positively charged. So once this carbon becomes positively charged, it triggers other bonds, the electron in other bonds, to start supplying the electrons towards the carbon to stabilize the excess positive charge in the carbon. So that is what triggers inductive effect. So there wouldn't be inductive effect if there's no electronegativity difference between the bonded atoms. So it is the electronegativity difference between the bonded atoms that triggers inductive effect. Okay, so and we have two types of inductive effect based on how electron drifts. If you have an electron withdrawing group, for example, in this case, chlorine can be called an electron withdrawing group because it is dragging the electron in the bond closer to itself. So, chlorine is said to have a minus I effect. That's negative inductive effect. It's called minus I effect. So, the inductive effect or induction caused by an electron withdrawing group is called minus I effect. So every electronegative atom or group causes minus I effect in the molecule. Then if the inductive effect is caused or induced by an electron donating group, as you can see, hydrogen is supplying this electron to the carbon to make that carbon to be more stable. So the role of hydrogen here is plus I effect, because it's supplying electron to the bond. So that is the difference between minus I effect, negative inductive effect, and positive inductive effect. So it depends on the group that is causing the inductive effect. Okay, so before we look at the other aspect of the topic, let us pause now and come back after now. Thank you. Alright, so that's all for now. In my next video, I will be taking you through types of organic reactions. So we're going to be connecting what we learned today to what we learned previously, that is organic reagents, where we talked about nucleophiles, electrophiles. So we're going to be linking it with different types of organic reactions, like the substitution reactions, the addition reactions, the condensation, but it's going to be basically substitution reactions and addition reactions. So you're going to be hearing things like, nucleophilic substitution, electrophilic substitution, free radical substitution, the same thing with addition reactions, nucleophilic addition reaction, electrophilic addition reaction, and free radical addition reactions. So that is what I'm going to be taking you through in my next video. Please, if you are not a follower here on Facebook, please follow my channel. If you are not a subscriber in my YouTube channel, please do well to subscribe to get updates of these lesson videos. Okay? So see you in my next video when I'll be demystifying the remaining part of the topic. Thanks for listening.